All right, let's do a vectors review. This is not a full lecture, and I'm not going to teach everything about vectors here. In this review, we'll go through the main vector ideas: scalars and vectors, adding vectors, breaking vectors into components, choosing directions and signs, and a quick look at dot and cross products. I will also point out the common mistakes students make and show you how to fix them. If you studied vectors before, these should all look familiar. The goal is to remind you what to do, why it matters, and how to use vectors correctly. Let's start with the basics. Some things in physics only have a size. These are scalars. Examples are mass, time, and temperature. Other things have a size and a direction. These are vectors. Examples are velocity, acceleration, force, displacement, and momentum. This difference matters because direction changes the answer. Even if the size stays the same, a different direction gives a different result. Vectors are usually drawn as arrows. The length of the arrow shows how big the vector is. The arrowhead shows which way it's pointing. This drawing is not just the looks, it gives real information about the problem. When direction is ignored or guessed, problems start to go wrong very quickly. Now let's talk about adding and subtracting vectors. When you add vectors, you're finding the total effect. This could be net force, net displacement, or net change in velocity. If vectors point in the same direction, they add very easily. But if they point in opposite directions, they cancel each other. And when vectors point at angles, guessing no longer works. This is when components are needed. This is the most important part of vectors: components. First, you choose a coordinate system. Most of the time, x is the left and right, and y it's up and down. Then you break the vector into two parts. One part points in the x direction, the other part points in the y direction. We do this because physics in the x direction and physics in the y direction are separate. Working one direction at a time makes hard problems much easier to handle. Now let's talk about signs. This is where many mistakes happen. Every axis has a positive direction. Once you choose it, you must stick with it. If you change signs in the middle of the problem, you're no longer solving physics, you're just guessing. When answers come out wrong and you don't know why, the problem is usually the setup, not the math. Vector algebra means adding, subtracting, or scaling vectors. When you multiply a vector by a number, the size changes, but the direction stays the same. Adding vectors combines the effects. Subtracting vectors compares the effects. There is nothing new here. This part is about using the vector tools in the careful and consistent way. The dot product is used when one vector acts along another direction. A common example is work. Work depends on how much of the force points in the direction of motion. If the force points in the same direction as the motion, the dot product is large. If the force is sideways to the motion, the dot product is zero. The key idea is simple. Dot means along. The cross product measures a turning effect. You will see this later when you study torque and rotation. For now, just remember this. Dot means along and cross means twist. This is enough for this review. Now let's look at the most common vector mistakes and how to fix them. The first mistake is breaking vectors into components but not paying attention to signs. The fix is to choose your axis first and stick with them the whole time. The second mistake is mixing x and y during the problem. The fix is to treat x and y as two separate problems and solve one direction at a time. The third mistake is finding the magnitude too early. The fix is to stay in components until the very end. Here's how to practice this. Pick 5 problems that use vectors. Your goal is not speed, and it's not just getting the final number. Your goal is a clean setup. Choose axes on purpose. Keep signs consistent. Keep x and y separate. Only find the magnitude at the end if needed. If the setup is not clean, the problem does not count. That's a vector review. Not every detail, just the parts you use again and again.